Hello, this is Richard Collins with the Internet Foundation, and I made a few tiny steps here trying to write some skins for some of these sites. It's one thing to see things clearly and to know what's needed. It's another one to sit down and do the coding, especially as tired as I am these days. Anyway, let's reload this. This one is fairly, did I blow it up? Oh, I was making changes to the program and I probably messed it up. So, and I have so much change there. Basically what I was doing was making a YouTube header and actually a YouTube skin. And so the button was up here, and all it did was a very simple thing. It just took this header, which is called something or other. Let's see, what is it called? I'm reading the program. Wikipedia, YouTube. It took the masthead up here and renamed it to header in my notes, and then took this and stuck it into a movable panel, okay, and hid the movable panel, and then put a button up here called header that when you click on it, it opens the panel, and when you click it again, it closes it, which is a way, basically what I ended up with was a list of items here to open and close the different things on the page. Header is something that I don't need to see every time. This thing here that has no name, they didn't give it an ID, which is basically why I sort of got stuck. This down here, which I don't believe has a name either, let me check if I inspect it. It's called, and I see there was an error in there, I don't think. Here, guides, footer. Okay, so footer I could have gotten. And sections. Okay, so that I now have two names I can work with. So sections. So what I'll do is see about moving there. The problem I have is if I move them to another new owner, then I lose the wrappers for them. So that was where I got stuck. That you can't refer to this one, the footer, or the sections by name. You have to sort of fiddle around and know how they shoved it in there. And so this thing here, what they were doing is playing games with, well, if you only have a few that you can show, then show fewer of them. And so it got more and more complicated. And this content container, let's see if I can move this off of the way here. Content container, there, okay, so maybe I could have tried that, but let's see, what was this? So, scrim, ID is scrim. This doesn't look like what okay, app drawer. Okay, so maybe maybe that was the thing. The masthead container, content, that one, ID is guide. Okay, so maybe that's where I had. Okay, it's just hard to read these things. You don't, HTML doesn't lay out the layout of the thing very well. What we need is here's a list of the major sections on the page. How do you break this apart? I had another thing that I was using a little while ago. It would highlight each section in red. So when you hover something. So this thing here is a major division, and it has a name, even if the people who wrote it didn't. So here's a big piece, the header, scrim maybe that's what it's called, sections, footer. So we could do these, and then basically what I'm saying is you don't need to show this all the time. They didn't put in their own transition, and frankly I don't think they need to. Okay. Suppose that you have a browser that can put a skin on this page. The content provider says, here's our scrim, or here's our sections, or here's our footer, here's our header, and you can put them wherever you want to. Here's our basic layout that we recommend there, and we have 20 million or 500 million people using this, and they voted on their favorite layouts, and 600,000 of them tried their best to come up with something better and more efficient and slick for whatever they were doing. Okay, you get what I'm saying? Now, I'm looking at Twitter because they want a recommender. And I look at it and say, yeah, you can go in and play games with looking at the things they're doing, but you could just let the people work together and tell you what they like. And what would that be like? That, for instance, in here, okay, I've got a beach thing in here. I'm looking at all the live videos on the internet. Okay, not just YouTube's got some good ones in there, but I don't even know how many sites now are offering live videos. So many private groups. They find, well, I can, put a wrapper and serve a live video from my website, and I'll do that rather than going to YouTube where things kind of get lost. Because there's no grouping. There's really no grouping. There's no science group over here. Okay, look at the things that are here: chemistry, mathematics, engineering, finance, welding. Magnetic motors. I'm doing a lot of stuff. I do a lot of stuff: electricity and magnetism, gravitation, international development. Okay, pretty much all of the things that I grew up and worked on all my life are not on YouTube. Well, actually, they are. Okay, because what happens is there aren't many very slick, efficient hosting companies on the internet that do a pretty good job of handling videos. Why did I say pretty good job, and why did I hesitate? Well, here's the thing. For scientific work, you need a lossless format. You can't just go and throw things out out there. If you're doing skies and that have real pixels with stars on them, it has to be there. Also, I think I bugged somebody. I do feedback on everybody, but most of the time there's no system for taking feedback, and so if you get a random person, what do you do? Anyway, so what I was recommending was that you allow different kinds of content. For instance, the poor people who come and want to put audio in here, they have to put a video. And you'll see these hours-long videos with just one picture, and it's there because they have an audiobook. But they could just as well say, well, we manage content. We're a content server company. It's not just YouTube. It's you content or something, or your content, or your stuff, or something. I mean, I like YouTube. It's a cute thing. Everybody's learned it. It rattles off the tongue. But if it got so rigid that it can only handle, certain formats of videos from, certain, you get what I'm saying? So, for instance, a live telescope feed could kind of go through YouTube. I've looked at groups. I'm talking to telescope sharing groups, and I went through as many of the telescope astronomy, but private and public, all different kinds. Anybody who's got a telescope of any size, a cell phone pointed at the sky is a telescope. Okay, so all those pictures and things could be brought together, but you need to be able to handle the formats. The deal with telescopes is, and cameras for that sort of thing, astrophotography, is lossless formats. So anyway, that's just one. So I'm not sure I got that down very well. Let me see if I can. I like that picture for some reason. Just take a look and see, and just whatever comes to mind. Okay. All right. Traffic cams. There are thousands, tens of thousands of live traffic cams out, and I looked at them for a whole variety of reasons. One, I think that it would be a great idea to have a global community studying and helping to write the best of the best of the best. Not Men in Black, best of the best, but all the way out. Let's really do it right. Let's get everybody in the world who has an interest in a skill and perseverance and all to go and try to extract information from there. And what will happen is a series of criteria and specifications for what do you need what kind of sensors and cameras and all do you need, which you can feed back to the camera industry and to the machine vision people and all. So it can be done in basically a more organized fashion, which is if there are just let me see the scale of this. Traffic this is what I do all day long. Traffic cameras or traffic camera or traffic cam or. Now the reason I'm doing this is because if you just choose a general one and let Google do it, they don't always do a good job. Cam. I'm not sure I got that. Just throw it out there and say about 9 million, give or take, 8.95 million. Okay, that's fine. Traffic. Let's put 2 C's in there and see what happens. Just traffic cam with this 8.9. No, that's so. Let's just take that one off. I know there is a term. Maybe I'll see it on here. What I tend to do is, I go in here, and so that dropped it back to 5 million. So but 5 million, drop it down. Be conservative. Drop it down by 100. That's still 50,000 groups out there who are involved in this in some fashion. Not to count all the people who watch these things and could use them much better. I have seen people put up cameras to watch intersections and sidewalks where there's traffic also shown. And so there's incidentally a lot more traffic information out there. And often there's things that are incidental that, where you can see the traffic from a distance, even if you can't see the wheels or something like that. Like in that bridge picture we were just looking at, okay? Wherever it went. Yeah, here. Okay, so there's traffic on there, and frankly, those are pretty easy to track and follow. Here's talk about crossover. Okay, a gravitational array. The detectors, the atom interferometer, gravimeters, and gradiometers are sensitive enough now that they can begin to pick up a bus that far away. Okay. Nobody's built them. Nobody's tested it. Everybody's quibbling and arguing over precedents and who's better and how much can we make off of this. But if they get out there and start trying it, you can use a traffic stream with cameras that are monitoring the 3D positions of these things and identifying the particular things that are there. So there's a nice big bus going by there. It has a gravitational signal. It is not big, but it's detectable. And part of the game you do, I want to do this with the moon, okay? And the trick is you do in front and back of it or somewhere else, and you detect bus or not bus, okay? You do really simple, is it there or is it not? Is it that's location or not? So say the moon were up here somewhere, and you're tracking it with a gravitational array. Now you want a global array if you can get one. And so you say, okay, LIGO has 3 detectors, right? That's it. That's the sum of their, and I think about 2 or 3 more, but they built these ungodly expensive ones. Now, the new generation are desktop or bus size, at least they're smaller, and there are atom interferometer chips and things, and you can push those out to the point where you can detect moon or no moon. So I've said this in another video, I think. I put them out there sometimes. I make them and then I don't always share them or stick them out there. It's just too much going on. So anyway, so that's just another use of traffic is to let's see. Oh, I'm just thinking of all the costs. The gravitational signals. If you have a beach, say we were watching, let's see, surf waves live or something like that. I don't know if we'll go on or not. It's not always clear there. I will show you something though. Okay, so here. All right, so here's no, that's not. Let's see, how do I? Oh, okay. So, sir, suppose you're on a beach somewhere close to this, and you put out some drones and generate a 3D map, 3D mesh of the surface of the waves in real time. What you can do then is because it's fairly uniform, the density of the water is pretty uniform. You can calculate the gravitational signal of that. So basically, you calculate the gravitational potential. Actually, you just calculate the gravitational acceleration of those blobs of matter as they would affect a nearby detector. And so you can do that. And if you run the numbers, you'll find that they're big enough for even today's detectors. It's just nobody's done it yet. But so crossovers. Okay, so there are groups. I mean, there's a bunch of groups that are doing surf, right? Okay, I think for very good reasons. I think anyway. So if you can take that kind of data and help the surfing group, predict them, track them with satellites, run your supercomputer and make sure your model is there. It's a good verification of your thing. And people have fun with the surf, they get a good prediction, and the guys get to constrain their their global ocean models, right? Or regional ocean models and their predictions. So, and then the gravity guys can go in there and say, hey, okay, let's use that. Look at the size of that thing. That would have a nice gravitational signal. And it is very, 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 okay. We're looking at this at they probably took these at 60 frames a second. So the cameras can do that. You can run a gravitational sensor array I'm trying to get them at megasamples per second or gigasamples per second. Then you can track the time of flight of the signal and see if it's arriving at the right time, as well as is it the proper amount based on the shape of that over time. Okay, so these should be fairly simple. I think they're coming in like at a steady pace, and you could do things. The idea then is to use the cameras, and I would put in an acoustic array too, because you can do that. So there's these neat, fun cross-sensor problems that you can do. Now, okay, so say you did that. Well, there could be 500. I'm saying that's small. 500 universities who want to have acoustic, mathematics, simulation, modeling kind of stuff. They want to learn that. Well, they could all work together, regardless of their size, internationally, and pool and put in sensors for a place like this, right? Okay. Somebody gets to have the fun to go out there and run the sensors, and everybody else gets recorded data, and you can check it. So, and it goes continuously. So some sites may be, for the next 50 years, they'll be monitoring, collecting data on the exact shape of the thing. Now, there's groups out there, the radiometer guys, okay, so you got machine vision, and what can they do? Well, they can come out and say, well, look, you see the reflection out there, that it's picking up bits of the sky. And if you go in different directions, you're going to find that, you can track the sun. So say, look at all those things, and from the light, can you tell me the exact position of the sun? Okay. Now, it's fun because things are moving around or jumping, the camera moves and all, so you get to solve these really horrifically complicated things, but you can do it. Now, if you go to GitHub, or you go to MATLAB, or you go to Mathematica, or you go to all kinds of online calculators or groups that are doing this, universities say, well, we're doing machine vision. You go and you look and you find a few pages, a whole bunch of paper, PDF, printed papers, literally paper, and not many, and some tools that they don't have time to do. But if you do it on a global scale and say, let's get every one of these and actually put the stuff together, so we're not building a thing 5,000 times one, we're doing one with 5,000. Do you get the difference? It's one organization with 5,000 people, 5,000 groups working together, sharing one set of models, one set of data, and affording to buy the data if they need to. Now, you can have fun with this because, say, you go and you find schools, and I've done this. I found high schools that make magnetometers. I found grade schools, I think, that have done seismometers. Okay, and they're all out there. Everybody doing it poorly. You get a city like Houston, where I live. I think they have 200,000 kids here, and every single class is working alone. So even if you get somebody who devotes themselves to physics somewhere, they are going to have a hard time have enough time and money and raising resources and buying the parts and trying to find things to make something. So you find somebody who does a good job, you help them. My rule is that every page on the internet, every single piece of content on the internet, I look at this here, okay, so I don't know, maybe I see something, I say, oh, I like that. Do you get what I'm saying? I would say, I'm sitting here looking at that, and I say, not only do I, for whatever reason, I just picked that first one here, but you say, I think this would be good, okay? Or this looks like it would go with the big wave thing. So, like dragging. Now, the clumsy way that you do this thing here is really awful. I have a few categories, but I can't like drag and drop things in there. And because it's all text, my eye doesn't do it. I'd love to have a nice little dendrite image. I'd like to have a little magnetic levitation icon. I'd like, for visualizations and simulations, I could just have a rotating set of little reminders. All sky cameras, there are so many of them, and so many that also see part of the sky. This is ones where they deliberately do it. I'd like to get Elon Musk to pay back for putting so much stuff in the sky and make sure every one of his satellites has a sky camera live 24 hours a day pointing downward for all the cities that can't see the sky anymore, and pointing outward so that they can see the sky. You get what I'm saying? So looking down, well, you might say, well, there's some privacy things, and I left my dirty laundry hanging out there. I don't want anybody to see it. But there's lots of parts of the world that that might add up. But anyway, looking outward, I think it's fair, because one sky camera, even with the norm, like you put a 4K camera on there, they're showing up. You could put it on the internet and share it there. And you could synthesize above the sky of every place if you got that many things. It's just data management. It's not complicated. I call it not hard, just tedious. That means a good engineer can do it. Even anybody with good devotion and time and willingness to work hard can get it done. Okay. Drones, laser interferometers. I actually added a couple more. We got electron interferometers. There's a whole set of stuff. AMO. Atom, molecule, optical. Okay. These are all the sensors that they're working on. You look at quantum sensors and the basis of them. It's atomic, molecular, or optical. I added AMOE, because all the electron stuff. Okay. it probably needs more than that, but I just add one little dimension at a time and see. So software-defined radios, Chinese movies. I do take a break now and then. I'm fascinated with movies generally because there's so much out there. It's just I can't absorb everything all at once. So I'm trying to look at all the people in the world who study history. I was doing that just the other day. So what do you do? What are the best practices? I was going through some paragraphs on Wikipedia where they had most every page has a history on it, but all those history pages aren't together, so they don't have any standards. It's not in a database, or it's not put in a form where you can basically say, let me look at all the history of electronics, segments on all the pages. So you can't cross-cut easily. So Wikipedia is not a database. It needs to be a database of knowledge. Right now, it's that many millions of pages of handwritten paper about things. It talks about things. It doesn't show things explicitly. For instance, it doesn't have any live cameras and satellite views. It doesn't have any live access to 3D models and simulations there. It doesn't have access to the Hubble telescopes. It doesn't have access to machine tools working or processes that are live, pipelines and all kinds of engineering stuff, signals of millions of sorts that you could go in and actually see live and use. Okay, so I guess I got all these locked. I don't know how to use. I don't really know how to use playlists. I can't learn every single site on the internet. I would like to, but I get tired. So maybe if I can figure out how to unlock these things, maybe I'll do it. I'd really like to get my drag and drop working, so I don't have to go and do this. When I see one, just say, here, drop it in that bucket, and then make sure. So how would I do that? I want to take these categories and just stick them on an overlay on the side with some nice little icons, and then I'll just grab and drop the things on there. These big ones would be easy. You just drag them and drop them right there. But there. So anyway, that's something else. Now, I'm getting distracted. So YouTube, let's see. Google, I put out a video. That video I just did, let's see, I don't even know, how do I get to my videos? Oh, brother. YouTube Studio, YouTube Studio. Is that where all my videos are? Playlist. No. Oh, ladies. Let's see. How do I open that thing? Many things just don't work the way I think. Okay, so I did a few things here. All right, there. Okay, so I can open that. I can open here. Come on, open. Okay, they took it off. I came here earlier and they stuck a COVID ad in here. I took the word COVID out of my title to make sure, to see if that would dissuade them, but it was Google sticking in. They got a group out there. They're working on COVID, right? Okay, and they're excited about that, and they feel like they're getting somewhere, and it's on YouTube, and YouTube says, well, this is a world good thing. You should do it, and it's good press, goodwill for everybody, and all. And to some degree, I don't know if they said, well, it doesn't really matter if you do anything, just do it because we have to. On the internet, I have to look deeply at the motives of everybody, everything, every group. That's the way you do balancing for the impact of society, of the internet on society and all. So don't take it to heart. I'm not beating on anybody. I'm just saying that's one of the possible motivations and things that are. My sense of Google is that on things like COVID, is they're not really supervised that well. Probably not supported or I would turn that off. Okay, not really supported that well either. If you're going to do what really needs to be done, Google, who owns YouTube. Okay, so it was a Google ad that came up. YouTube, they own YouTube. I'm pretty sure that's right. So Google for COVID ought to go in and share their global database of index of all the places where COVID is mentioned on there. They should take, and for instance, the Gov domain, they should give feedback, a database of all of the places COVID is mentioned on there. And as well as their machine intelligence can go, what they ought to do is go in and identify the context, the owners, and purpose of each of those things. Okay? And then from the inside, all the Gov domain people can go in and identify, they can dig and say, basically, it's let's get there. It is not good for the human species if you build monopolies, centralized, single message kinds of things. If you put it together, you can't throw anything away. Literally, that's my rule. It has to be a perfectly lossless, zero loss. What does that mean? If I take 7.5 billion fragments of things that mention, pages that mention COVID on the internet, not only do I have to bring the individual, fragment, the page context, the organizational context back, I have to, when I put things together, I can't throw any away. So if it says wash hands 3 billion times and it seems like, well, that's the only content that's on this page, it's not. You can't just take the category and collapse it because the context is different. So you have 3 billion wash hands pages on the internet. You take them and you say, here's 3 billion times that people are concerned with this. Can we find, first of all, that's a community of 3 billion groups or people or situations. Take that and talk to those people. That's the point of bringing things together. Okay, so I've walked through this so many times. I go through and I try scenarios on these things. I did a whole bunch of World COVID status reports last year. They're really good. I got 13 views. That's some really good. I do really good work. Anyway, so all right. So I was having fun looking at big waves, traffic cameras. Okay. I live in Texas, so they always keep throwing it. I would like to say, Google, do not use anything that you know about me. Turn all that off. Now, I don't want to go into anonymous and all. I just like to say, give me a true and fair thing. Actually, what I would prefer more than anything else, you say there's 5 million pages, right? We'll prove it. Show me a random sample of 10,000 of these 5 million, okay? That's not a big sample. What is that? I can't even do, my head is hurting. Okay, so that's 5.13 million E6 divided by 100,000. 10,000, a sample of 10,000 out of there. 513th, about 2%, okay? So 10,000, give me that in a database form, a nice, maybe in a JSON structure. JSON duplicates everything. Just a tab separated file with not leaving anything out, including links to the things and whatever you know about that. I'd like to go a little bit deeper. I'd love to get a better scan. Then I would take and look at 10,000 things. Google Ngram is a cute thing. I went through and extracted all the unique 50,000 of the top 50,000 words in there and their counts. Then I sat down and manually categorized all 50,000 words according to how they were used. And to some degree, how they were impacted on the internet. It took me about 18 hours nonstop to do it because I had to keep all of those words in my head at once and all the categories that I was doing. I had to play games to do it efficiently. But you can. A human can do that kind of stuff. There are people probably way better than me at that. But I did it. The whole point is that there are people in the world who can do really wonderful things if they have the tools and the data. Mostly people don't have the data and they don't have any tools. So I think I recognized that way, way early on in this. In my first year of the Internet Foundation, 1998, I recognized it is easy to make money on the internet, to entertain on the internet, to chat with your friends on the internet. But every single serious problem, how do we run our city? How do we communicate with all the people in our city? How do we educate our kids? How do we run our factories? And how do we determine the needs for things? How do we solve difficult problems that cut across states, or how do we problems that cut across countries? And let me not get into it. It's easiest. The only way I can do things is I take each thing at a time. Like I say, I mentioned this in the other. I go through all the web policies on the internet. Now, go through. I was doing the AC Stark effect. This is basically you send a field through a material and you look at it with different sensors. So it's a time-dependent signal that you're sending through a material, and the names for this are multitudinous. And there's a big gap in here in terms of sort of the quality of the material around low frequency. So when it says AC, generally what they're talking about is electrical circuits, usually less than a megahertz in there. But it's filling in, and on the internet, because things fill in and the groups begin overlapping, every single time they come together on something like that, there's huge waste in there. As people learn individually, one by one, they have to learn the interfacial translations between their field and the adjacent ones. So here, this was a pretty good optical dipole traps for neutral atoms. Okay, so they've been doing this for decades now, but I found some other. Anyway, so I can read all of these now. Okay, and actually I'm almost good enough to write and change some of these. The reason is most of it's pretty straightforward. There's only a few hundred basic tools, sort of mathematical and computer tools that people use. On the supercomputer network, linear algebra, those big iron supercomputer exascale kinds of things. I'm not being demeaning. I'm not trying to diminish what they're doing. I'm just trying to give a name for people to say, look, they're out there doing they're doing huge things, but the core of it is often quite simple, and if you follow the pathways from what they're doing, it affects the whole world, but they're not watching the whole world. And literally you can't. Okay, when I go here, if I want to go and see everybody, let's just take this Outlier Towns. Okay, I don't have my Wikipedia on here. I'd close that, and just look at the text. I'm a viewer. I'm a user. I'm just reading here. I'm not going to edit. So what should this page do? I'm in reader mode. Okay, I should just say reader, editor. Like if I want to edit, there should be a button that says edit, and that's all. You just slide it. You turn it to reader, or turn editor off, and you don't see. I don't need all this stuff. I don't need to be logged in. I don't need my edit history. I don't need to talk. Now, if I want to, there ought to be a community on here. I'd like to talk to people about Outler Towns. I don't want to talk to them about editing the thing. I want to talk about using it. Where is it? What kind of sensors do you have? What kind of data do you have? Who's doing it? Where can I find some online examples there? So this could be a wonderful sharing place, Now, the old idea, in the encyclopedia, I read my share of encyclopedias. When I got to Case Western Reserve, the first thing I did after I got a job was to go. I was with the mathematics department, by the way, helping kids do numerical calculus. Anyway, was to go to the library, and I just picked a shelf and started reading, and I just read. I can read so fast I can just pick up a book and read it and do the next one. But their encyclopedias and their reference works were way better than anything I'd ever seen. Handbuch der Physik, I was just fascinated with it. I learned German and French, in high school, because at that time you were supposed to know those just to be a physicist, just to be a chemist. But then that same year, they said, well, you don't need that anymore. But anyway. So let's do Outlet Towns. If you search here, 40,000. But if we're going to do MEMS properly, they need proper terms. So people have variations on that, and what I would tend to do is to go in there and set up for each different topic and say it's in your interest, Outler Towns global community. Okay, that's the way I think of this. This is I hope I'm pronouncing that right. Outler Towns global community. Okay. And that's all the people in the world who have to deal with it in some fashion or another. Now, if it has alias, it's also called the AC Stark effect. So I think that's gonna. You can say, okay, I'm looking at the global Outler Towns or AC Stark effect. Literally, that becomes the name of a group. Okay. If you think of it that way, then every time you do one of these searches on here and you get this large numbers, so anyway, this is not a large group, but it's an exciting and tightly, or it could be a tightly woven group. It crosses every country in the world. Okay. Now, it used to be a little bit easier because I only had a couple of hundred of these, and so I could cite China, what's happening in China, right? Well, there's a couple of thousand there. But then I have to say, well, can I do this as in Chinese? I think for global research, for global there. Now, what does research mean? It means go look at something that's already out there. Do it again. I think that's what it is. Now, it's not exploration. I would say go explore. Go explore. Do it for the first time. Mapping. The early American explorers went for the first time, some of them singly from coast to coast, and then they came back and told what they did. So, sorry, I'm going to really tire. So anyway, that's the way I'm looking at these things. And for Google, Google, you don't do a good job of these at all. You're doing a horrible job on it because you don't even address it. Okay, somebody does a search like this, and well, look. What are the major organizations? I would like to see. See, it says AC. Give me a breakdown by of the AC. Which are the organizations here? Okay, I don't want to have to go in. I should be able to hover that, and it tells me what the university is. It says IPHY.AC. So it's academic. So AC is generally a university there. Now, I also know that there are tons of government research projects in China, and many of the technical schools. I don't know how their education system's broken up, but my guess is it's probably like the U.S., and there's academic and then there's technical split on a lot of things. And there's a lot of companies that are out there doing research, and that stuff's split all over the place. They need partners and connections and ways of doing things, and that part of it is they can do it by finding there. Anyway, AC, that's the same. MedSci, laser spec. Yeah, that's another EDU. Okay, so there, EDU. Okay, so all right. Maybe I picked some really hard ones. Let's try something. Welding. Laser diode. Okay, some fairly easy. Okay, 549,000 there. Now, here you get to people that get out and they graduate from school and they go out and they get a job. And many of them say, I like what's going on out here, but I want to do more. So they start their own company. Some are really small, or they go into a larger company and they start a new project. But ultimately, it's a development and exploration kind of thing going on. And then that's where most of our tools come from. Somebody way back when said, I want to build a laser diode. And if you track back just on laser diode, let's just do that. There's a bunch of there. Now, Wikipedia gives you one page, and they don't list all the players. They don't even tell you how many people are working on it. They don't tell you how much the jobs are worth. They don't tell you the market value of it. Okay. They might incidentally, depending on the thing, but as a general thing, any topic on the internet has these economic, social, financial, and most all of them have computer, mathematical, engineering dimensions as well. Okay. So anyway, the guy. My brain is flipping through all of the different projects that I have where people are expanding the uses of lasers. The 3D lasers that can write in air, that fascinates me, especially if you go in. I looked at the industrial applications of lasers in fields for chemistry, industrial chemistry, for pipeline. The exhaust from the crazy shuttles and rockets there are conducting plasmas, or can be made so, and they can be scanned and manipulated with LiDAR, ionized selectively with lasers, controlled by electric and magnetic fields. And you could, I was watching the one, they had one, right, Elon Musk, he sent one of his ships up and then basically back down again. I don't know the path. It just was like 5 or 6 minutes, up, down, okay. Well, it was actually up, and I don't know where it went. But anyway, but what I was looking at, the camera showed the rocket exhaust, and I was thinking, look how many complicated iron, it's not iron actually, but you know what I'm talking about, solid things with lots of wires and things, and you know, you could do the same stuff with electromagnetic fields, not just static electric fields, and magnetic fields, which is where a lot of people get stuck, but the electrodynamic, the dynamic, in real time. And that's where things like, if the schools would teach, let's see, Frank, let me check one more, see if I can remember it. Frank, there it is, Condon. I knew it. This is a classic experiment, and let me see if I can find it. Maybe they have it. It's an ionization. Oh, wrong one. I think I got it wrong. Condon principle. That's right. Sorry, Frank Hertz. That's what it is. Okay, I'll get it right. Okay, I think it's the same. Frank Hertz. I think it is. There it is. Frank Hertz. Okay. You see those plasma globes. It's the same thing. An electrical current going through a gas ionizes it, causes some of it to emit light of all kinds of frequencies, and all the way down to 0 frequency that it doesn't quite exist, but down to like the gravitational frequencies, the microhertz and the nanohertz, those kinds of frequencies. But with this, if you go, I went and looked at the schools that are doing this experiment, and I found and read a bunch of the lab experiments where they're doing this and and everybody had to hack it together, right? And they had to hack together the mathematics and all. They didn't have anybody to turn to, okay? If the professor said, well, here, I did it myself, but more than likely they picked it up from somewhere. In the globe, okay, in the global world we have now, all of the people doing this experiment can share the same model sharing area, okay? Just like you have GitHub to share, computer programs, you can also do this. Now, it only shows 126,000, so it's actually, the reason I picked it because it's fundamental. It was the basis for basically understanding sort of avalanche and cascade processes, ionization, negative resistivity. Most of the semiconductors follow the same sort of thing. So it's a good fundamental one. And for applications such as, let's use electromagnetic methods on optimizing, use our supercomputer methods on optimizing the combustion of a gas and the exhaust, with optimal thrust and control. So you could with fields, you can change the flow, the frequency, and the composition of the exhaust from a rocket. I've thought of this since the first time I saw that back in high school. I lived at it was Cape Canaveral then, and so and we'd see the big ones going up. So it was 1964, 63, 64. Yeah. Anyway, so these are cool things, and I'm just picking things just off my immediate memory. Let's see. Okay, Plasma Go. Let's see. Internet byte codes. Oh, Winds and webcam. There's a whole bunch of stuff out there where there's information you could learn about wind. So I was trying to see how much could you pick up. If you have multiple cameras that see the same clouds, there's on-purpose studies of this, but the incidental capturing of, multiple views of clouds would be useful. I'm trying to find ground-based networks that will calibrate and give ground truth to the atmospheric meteorological weather models. Okay, they have all kinds of names, different purposes, different groups. This one, I come back here. Sometimes I like here anthropometry, the measurement of humans and human interaction. It's a huge and wonderful field, and the people globally. Okay, maybe you get a few people in the U.S. and they say, "Oh, let's get everybody together," and so they do like 10 groups or maybe 50 groups in the U.S. and then they stop. Or let's do something international, and they do 5 or 10 countries, and then maybe they do 50 universities. Maybe they spend a whole bunch of money and they get maybe a big conference. Well, they pay for people to go talk to each other, and then everybody goes home and forgets it. So if you spend the same money and build a place where people can share continually, then you could work on anthropometry, which has implications now for all the gaming, the 3D gaming industry. They make characters all the time, and most of the machine vision to pick up gait and I can see the words, I can see the pictures, I can see the pictures, I can't see the words. Anyway, you'll get an idea. I went through blockchain again recently. Somebody was doing that, and so I went through that in detail. Tropospheric models. Actually, that one got in and it's thrown in as they. I have a huge, intelligent algorithms. This is called, when you see an underscore in here. So I took all of these things here and then each one of those is fairly. So that's Project Gutenberg. I saw that on a Regeneron group. So sometimes I'll write reviews and comments to these. So like Regeneron, I sent them some comments. I seem to recall. They're doing stuff, but the kids are not getting the benefit of it. They gave a lot of money to a few kids, and what they maybe should have done is spent some of that money so the kids could talk to each other all the time. And it is possible to have a way to do that safely. The kids are going to have to grow up. They're going to live lives working globally. They're going to have friends working on the moon. They're going to have friends working on Mars. And I'm pretty sure the groups, I track everything. And one of the things that's going on is there's a bunch of people who talk seriously and practically about faster than light communication, and it keeps coming up more and more. And I'm talking about random places, people doing a serious paper on quantum detection, and then they say this implies that you could have faster than light. And then somebody else says faster than light communication. And then somebody else will say, well, I was doing quark gluon work, I was doing that, or I was doing string theory, and it said this, and you gather all those up and begin to see, is there any substance or I don't make any judgments on a lot of these. What I do is here I'll go in and I say, well, I find 50 or 100 or 500 of them, and if I have time, I'll go through maybe a couple of 300, and read them and try to translate all the different terminologies in there. I can do that. Just as the way you have machine translation of human languages, you can also translate all of the scientific languages. They're actually slightly easier, but you need a human to do the teaching. And what do I mean by that? Because only humans have a lot of the information to resolve the ambiguities involved. It's not that the human is giving methods so much, but rather specific information. It says, is this thing over here the same as that? Okay, there's a bunch of that. Now I can do it myself. When I'm reading them, I just provide that kind of stuff. And then, electroosmotic flows. I have to go through every single pair of things. So you got electric and magnetic and gravitational, acoustic, But when you stretch those across from picohertz frequencies up to let's see, what is zeta? I think it's zeta on the other end. Zeta hertz. Okay, we cover that whole range, and if you take all the combinations of those, that's what the human species is investigating right now. Okay? So there are people who take the equivalent of, say you're looking at something, and and in that frequency range, high frequency is 1,000,000 times higher than your norm, right? Okay. And low frequency is 1,000,000 times smaller than your norm. So you pick a center frequency anywhere, and you go up 1,000,000 or down 1,000,000 or up 1,000,000,000 and down 1,000,000,000, and you get in, and basically people use their experience to name things, and so they say high frequency if it maybe goes up a factor of 1,000, or low frequency, or high voltage. Well, I'm working at 1 volt, and 100 volts is a high, or 1,000 volts is high. If I'm working at 1,000 volts, maybe 1,000,000 volts is high. You get what I'm saying? And because of this structuring of human knowledge on the internet, I had to go in and find all those powers of 1,000, find all the variations on the units, make sure the units would transcribe into there, and then put it into a single sort of a giant matrix of because when you're searching, if you're trying to build a good efficient search thing, is this going on? A lot of times you can actually just calculated almost. Okay, you can say, look, here are the basics. We have this kind of technology. There will be a group working on this. You might not know it right now, but you can just about guess. Look, everything in the gigahertz is fairly covered. Everything in the megahertz is fairly covered. There are gaps, and if you know where the gaps are, you can make a prediction, and then you know how people fill in those gaps. You'll know where to look for the other pieces. So all of this stuff fits together. Now, I'm running out of time here on this thing. Did I cover, what did I wanted to show you that little thing. I wish I had somebody to help me write things. I mean, I'd love to go in and hear, let's see, what is it? Okay, bispectral analysis, orthogonal functions, analytical functions. Okay, mathematics has a rich contribution to all the sciences and engineering and all the quantitative things. But the unfortunate thing, most of the time it stays on paper, and the engineers need calculations. Engineers need simulations that actually run. Now, most of them can't afford, unless they work for a big, really expensive company, they can't afford to go buy the mathematics packages. What they could do, though, is you could go in and say, if you're doing mathematics and publishing on the internet anywhere, in any form, you ought to, I won't say you have to, I say you really, really, really ought to put it in a symbolic form, in a form basically that's compilable. What I look at a system of equations, in a sense, I say, to make that operational and functional and useful, a tool, you need to be able to manipulate the symbols automatically and be able to trace it and check it. You need to be able to run numbers with it if those are appropriate. If it's not numbers in the traditional sense that it does a calculation of a quantity, you can count states and combinations of things, and there's a tremendous range of methods out there in probability and combinatorics and statistics and machine learning and machine vision and things like that. What would they do? Is you say we don't know the exact value, but we can estimate a probability, or we have estimates of probabilities and we can simulate. The second job I had was with the State Health Department in Texas, and the first thing I did was go to the Center for Disease Control in Atlanta and learn about let's see what the term. Oh, my brain is starting to fry. Stratified sampling. Okay, so you're doing a survey of a city. You basically want to break down and get the proper categories of people. So when you get the results back, you have the categories and the framework for using the information. So I studied tables of data, survey results, and I did that again at Georgetown University when I worked for the Center for Population Research. And what I found was that you can, in fact, use any table, tabular data like that, to do simulations. It gives you there's a very, very, very efficient ways to turn tables of numbers, broken into categories and strata and groups, and turn that into a predictive model or a simulation. And so anyway, I actually remember in college, I was at a point where I was studying chemistry. That's what I started on. And I was thinking about physics. I was thinking about mathematics. But I said, I better check. And so I looked into, the commercial uses of computers again. And GE had a network And the guys using that network were the non-parametric statistics people. So that's what I studied. I think that was kind of deliberate now that I go back to it. They had access to that computer, so I went there. But the social use of computers is actually larger than the scientific use. It's just that it's so spread out and people don't study it as a science as much, or it doesn't get talked about as much. But running a good city with a decent accounting system and a good project management and estimating clearly and quantitatively what's going to happen. When I worked at Georgetown, we did long-range plans for countries. They were basically accounting-based systems where you just took everything that you knew and used it as a constraint on the model. And so you would say, well, how can I use this information to constrain what I know to make it more real? So the model is literally a scale model in a sense. This is what society looks like now, so it's a model, a static model, and then basically what are the rules that allow you to see that into the future? I don't know if I'm saying things. Let's see. Oh, magnetotellurics is something that's only a fairly new study. I've been tracking it all my life because it's been going on, but there's a lot of new techniques that are going on, and they're actually able to see much more clearly. And basically the dynamic magnetotellurics, basically the active transmission of fields in there, they were using lightning as the source, okay, partly, but they found that with more sensitive detectors, they can go in and transmit signals into the ground, and then look at the reflections and scattering of that. I wanted to compare that with the gravitational networks and seismic networks. When you begin taking, you say, okay, let's go here. It used to be, okay, you'd say, okay, I want to do a study somewhere. And you go out and you couldn't find anybody who had any data. And everybody's data is in a different form, and it was so expensive for the sensors. You're talking millions of dollars and tens of years. But now, you can use cell phones for a bunch of this, or people can get an Arduino and some wire, and they can send off on the internet and have a coil made, or they can, they can adapt a vibration sensor that's used for industrial, machinery monitoring, and they can adapt that, for something. So there's tons of things going on out there, which is hopeful for the poor people who start on Mars for the first time, because, well, the very first ones might be okay because everybody, oh, this is really interesting, let's give them everything they need. And then the next ones is, well, you're just another Martian, who cares, I don't care if you're starving or, you had to sell your house to move to Mars, you wanted to, that's where the bright new future is, all the jobs moved to Mars, I've heard it before. Okay. So, all right. Well, when I get tired, I get a little silly. I'm sorry. I see Weber Bar up at the top. Joe Weber, I think, is a very important figure in science, and I think he didn't get a fair bit there. He had already thought that he had seen a correlation in there. And it's hard. I mean, how do you know whether something's true or not? And a lot of thinking about what he was going through when he was saying, well, I got basically a false positive. How do you verify it? Well, now if I'm setting up, because I kind of design problems that I think are going to be done in there. So people will be building gravitational arrays of all kinds for a different thing, to monitor the waves on the beach, or monitor traffic, or in a building, all the that stuff. They're tracking packages and things. You can do that with gravity as well. It's just lower frequencies, more sensitive detectors, slightly. The mathematics is nearly the same. The computer, is all the same. So you have a computer, you have a very sensitive analog sensor, you put them in an array, you do your correlations, you figure it out. And what does it tell you? Well, something moved over there. And if you have these things, SAR, the synthetic aperture, I don't know if I even pronounce it right, synthetic aperture radar, has wonderful power because it takes a lot of data at different points, and it's a known and easily quantifiable position. And to some degree, if you put an accelerometer and a gyro, along with your sensor, you can pick that up very, very precisely. And what I'm talking about is that you should be able to go in and start imaging using gravity to image things like trucks. Okay, when I mentioned that, I saw a picture of a truck where you're using gravity to do a 3D scan of it. So I got a pic, like they do those X-ray pictures in the port where they're scanning the big container ships, the containers from the ship, and they're using these, gamma ray and it has to be up in the gamma. Anyway, they're using high energy radiation, and they probably could just as well use gravity. But in a lot of ways, it doesn't really matter whether, let's use through-the-wall terahertz methods, let's use acoustics, let's use infrasound, let's use thermal sensing, let's use, let's see what else, let's use gravity. So all those ultimately are sensitive analog detector arrays going to amplifiers, stable amplifiers, good reference signals, reference voltages, powerful and fast ADCs, analog digital converters, low latency storage and monitoring. So not only should you just store the data coming from a sensor, you also ought to be looking at it in real time. What does it take? You just stick 2 or 3 or 4 or 5 processors on there and have them each look for something different. Say, hey, well, you monitor the min, max, mean mode and count all the values in here. That's all your job. You'll see it. It's going to show up on, it shows up in the buffer. You just count every time you see something occur in the buffer and all, and we'll make the signal, the signal when it's latched in there strong enough that you can pick it up. Okay, so, and you do that. And another one says your whole job is just make sure it always gets stored. Okay, dude, there. So the things are so cheap. I mean, I buy I don't have time to use a lot of these things. I buy the crazy computers, and I look at them, and then I set them on my table, and they just remind me about a certain group of people. So I don't even have time. So all the Arduinos and the Jetsons and Jetson Nanos and the Raspberry Pis and the Pi Zeros and all of that. Those are fun things. And I have cameras, all kinds of cameras. I'd love to take time to look at the data from them, but they're in the time that I can do 10 or 20 little problems, I can go out and help thousands of groups. Okay, you get what I'm saying? It takes that much there. And so say I go in there and I'm good enough to do as good as like 20 people, okay, maybe, I'm totally efficient on something, I'm that good I could do better than that. But if I could help 20 people do their job better and just hand them the tools and make sure they got everything right, isn't that as good as well? And I don't know, I've always been a helper in my life, and maybe that's why I'm doing it. I'm saying, well, okay, you got this exascale wonderful supercomputer going on. Are you helping all the students going through all the schools now learning those things? Okay, and not by giving them canned things books they have to read. Okay, here, memorize these things. No, give them real problems. Give them that experiment. Okay, Frank Hurt. Say you got a group here. We got 50 or 100 or 1,000 universities. I think there are 25,000 universities, and then there's all the colleges and universities and the online groups and the high schools that are now more and more sophisticated. They could do this. And say you got all of them in there, and they say, well, look, we're trying about 50, we're talking about 10 different variations on this. Everybody's sharing their models. Everything is totally instrumented. All the data is being archived. We're going out there, and we're going to push the envelope on there. And what you're going to find is, just like I'm seeing with the those plasma globe studies, it gets really sophisticated really fast. And if that stuff's available, then people can say, you can do this, you can do that. And you can pick it up and actually look at the data and see. So you go to a university, you may never see any data except whatever you might scramble together. Yeah. But now you can have 50 universities doing best in the world gathering of the data, and you can go in there and analyze it and look at it. You can look at the camera images. You can, you can say, hey, can we get can we go in there? I'd like to look at, a nanoscopic view of that thing. And probably somebody's done that, and you say, oh, okay, let's get your stuff in there too. So the supercomputer guys, well, you need to share this somewhere, and I tell you, most of the server farms out there are getting weaker and weaker. Okay, they oversell them, a lot of them, and even though they say you're getting more, a lot of times I think you're getting less. So for the normal share this HTML image page kind of thing, and even for a lot of large groups, some sites are just slower than molasses. And they really ought not to be. There's big corporations even sometimes. That's a little just too much stuff. They just But so you could use the supercomputers and for the social good for the whole world, for the internet, for the human species. You could go out there and let them be servers. They're big iron, fast as everything. And because of the huge size of some of the memories, you could do some types of integrations that you couldn't find otherwise. Say you had, now I'm being really practical here. Say you had 10,000 people working on Frank Hertz. Just this. Every person has to have a lossless contribution record. Everything that they do, every conversation, everything, it needs to be tracked. Now, it's not intrusive. What it is say you go in and you use this and you design a better rocket exhaust control system. Okay, it improves the efficiency of rockets by a factor of 1,000. Because I think there's that much oomph and availability in there. And it's what I'm talking. If you did this, what you're going to find is that that all the groups that are working in the kiloelectron volt bond range, okay, these people, the chemical guys are like 10 electron volts per bond, right? You could go out and look at the 100 electron volts or 1,000 electron volts there, and your energy density goes up correspondingly. So you could have a 1,000 electron volt reaction that you used in your as a fuel, and it would be 100 times more compact. Okay? It works that simply. Now, do you need big computers? Yeah. Do you need lots and lots of people working on it? Yeah. Do you need to track everything ruthlessly and not let any small group go in there and try to game it for their own benefit? Even more so. The game, when you're working across all countries, all universities, all scales, all kinds of individuals, it is possible. I've worked with government industry groups, and you have legal oversight, you have accounting, you have outstanding accounting, and you use the computers in a lossless and open way. The open is there because every participant in there has a vested interest in knowing that everything's fair. So in the whole world, when we say open, in a sense, we're saying checks and balances. Everybody can see what's going on. No one is hoarding or gathering stuff. Right. I don't know why. I'm just going to get used to making these long videos because there's so much to say. Now I can't resolve all of those things. And I'm studying history more and more. What I find is that people go out and they say, these are the right things. I was telling my sister earlier today, and she was going on about, these are the ways we ought to be able to do things. And then she was throwing up her hands and saying, well, you can't get groups to do things. And I say, what you can do, I think, is you can get the computers to do things. And when the humans are interacting with that and using the computers as a tool for storing the models, the data, the transactions, that means all the flows of data going in there and all kinds, including their own actions. When I was in high school, I studied random neural nets. And if you go, you're going to find a dinky little story about me that I wanted to be go into biochemistry. I wanted to study the brain. Now, I could see in those days, that's 1967 about, is when, 66, somewhere in there. I could see that it was possible to, at some point, go in and have direct connection between the human brain and computers. And so I tried to build EEGs. I tried to learn how to make amplifiers that, because those were considered terribly tiny little signals then. When all anyway, what I'm getting to is that I think we're not anywhere near the limit on what we could do, to get individuals there. But we have 7.8 billion people in the world, and many of them are, in a sense, underemployed. There are countries that are training people. The U.S. is probably that way. People get trained way beyond what they ever get to do. Okay, because you need data and tools and resources to do a lot of stuff. And so you could learn all the theory and all kinds of wonderful stuff and never get to use it. I think India has some wonderful people. Actually, every country that I've looked at, and every person, when I go talk to people, my dad used to talk to, I'll tell you, anyway, you talk to everybody, and just in a few moments, you can find that they have deep inner resources to understand the whole universe. They understand people around them. They understand society. They understand a lot about what's going on. They just don't always have the words to say it. If you get a good observer of the world might have wonderful visions of things and just not know any of the words, at least for sure. So some of what I'm trying to do is get it where can you get people if you get like 10 different languages, everybody nobody's speaking the same language, and you want to work together. Well, what do? Right. In the old days, you go up to the blackboard and you start swapping equations and drawings and diagrams and electrical circuits and estimates of voltages and currents and the usual sort of thing. Now you can do the same thing in a spreadsheet, in a simulation, a model, symbolic thing. But like I say, there's only about 100 core methods in physics when you get down to it. And what they are is ways of fitting data. You fit curves, you say this model works for these kinds of things. And I pretty well have gone through all of them. I started gathering and learning them and trying to use them all when I was a teenager. And I've been at it for over 50 years now. Now, I'm going to, in another year or two, I don't know how long, it'll start disappearing, So I think part of what my urgency to try to get this all done is to, see if I can't get the basic tools on the internet so people can, they don't have to memorize this stuff. They can just go put the pieces together. If you get a system of equations, there's standard ways for gathering that. The mathematicians have done some of that extraordinarily well, and other ones they don't seem to have a clue what they're doing. I mean, they manipulate it and say this equation is totally isolated from that. But every you go to analog.com and look at their technical notes and look at the devices they have and the services they offer, and they're putting together workable systems more and more. You go to groups like let's see, all about circuits. I'm sorry. What I'm saying is that the people recognize that in order to do something, you need all the pieces, and the pieces, basically the model, the simulation has to be as good or better than reality. There's even a name for that, which I can't remember at the moment, which is something like, you don't let somebody go in and run a nuclear, a nuclear power station. You have to train them somewhere. So you run them on a simulator. You don't let somebody run a expensive device of any kind without some training. But you can make the things almost as good as real. Sometimes even better, because you can go in and run it way beyond where it was ever considered. So, all right, what else can I say? So I'd like to say nobody helps me. Nobody ever even asks me questions hardly. Probably nobody knows what I'm doing. But I see something like this. I did write some suggestions to a few people about this, and they're just. The thing is it takes time. Okay, now I don't have time to do it. I'd like to get some tools, basically scanners, and talk about mining on the internet. It wouldn't take much to go find all these. How many were there? 126,000 mentions of that exact phrase. So that's a very specific and highly specialized thing. Could at least locate the URLs, identify the organizations involved, check the departments that they're in. So this is in physics and astronomy at GSU, which is, I have no idea where the Georgia State? Probably, maybe. See, this is Pasco, this commercial one. So they sell some of these things. Now, I don't see any reason. Okay, where did the people go? Okay, you get out of school, you get a job, and you work for Pasco, right? And if you're a good engineer and you learn this stuff, you might know more about that than almost anybody else out there. Now, the thing that I try to do is try to be fair. Say you go in there and they say, "Oh, we want to gouge you for the." These guys are probably okay. If there are critical, say you you want to get something, you found a way to go and make 100 times better rocket ship. Okay, we'll just make it easy, something like that. And some of the critical pieces were in there, and the whole thing get held up. Do you let one company basically extort from all of society for their own benefit? To some degree, that's happening a lot on the internet. Okay, the people there now. I'm not beating on you. I think my guess from looking at this is that would be good. So, anyways, here's a university doing an experiment. Here's another university, another university, another university. I looked at that one. I read that one. I'm not sure where some of these are. So these are cool. Okay, and it was not what I thought. Okay, I thought that the ionization stages were more sharp and now it could be that you go in there and you change the frequency, the voltage, the accelerating voltage. I bet you it has a wide range of things. If you go into plasma physics, there was a huge number of plasma experiments. And they bolt in there. But where do you start? Well, you might start with something this way. Part of it is sort of a pre-competitive, pardon me, low-cost experiment that can be done anywhere, and that has kind of a historical basis, and that's been around long enough that there's a whole bunch of people who've looked at it in different ways. looked at some of the older stuff and say, what did we miss? What could we have? What could we come forward and look at? So I've used up my hour and a half. I think I'm just going to do 90-minute things here. 3D Scientific. Hey, they got a Nobel Prize for it. It must be good, right? That's the drone. I see the power supply in there. The drone power supplies are adroit, lightweight, and powerful. Okay, they have to be, and they're also fairly easy to learn and use. Okay, now they have their jargon as bad or worse as anybody else, but the some of the stuff in there is very worthwhile. So, and then the electric car people drove the battery, so they're getting better, and the supercapacitors and the things. So you can get a lot of power, lightweight, relatively low cost or adaptable, and the thing is you have programmable control over the frequencies involved. Okay, so you can actually say, look, here's the FFT of my signal, and let me just generate it from that. Okay, and you can constantly revise that and say, here's the FFT that I put in, here's the FFT that I put out, here's the generalized transform that I can use for the the first estimate of there, and here are the power series of the differences, each with their FFT, to revise it. So you can play some cute games with those sort of. Now, can you do the same thing with linear algebra? Yeah, but the orthogonal representations, the things like wavelets and all, a lot of them fit the actual behavior of the things that are in there. So there's ways to improve it. Let's see. The AMO guys, the atom molecular optical guys, and I'll put the E on there, atom molecular optical electron or electronic guys, make sensors in arrays. Now, all the memory sensors, all the camera sensors, many of the processors that have arrays of these things are also very sensitive sub-light wavelength detectors. Okay, so I'll just throw that in there as something I was working on early this morning, and so the IBM's 2 nanometer resolution, I think that's what that is, the precision with which they are drawing the things is good, but I think that the way in which they built it has the potential for making essentially pico-scale metamaterials that people could do. Now, I'm just throwing that in there. It's more of a reminder to myself to go look at that in more detail. So, I work on Twitter for a while, then I work on web policies for a while, then I work on find all the people in the world working on this. I was looking at it just goes on and on and on. I'd like some help to get this out and share it with everybody. I think I only have about 12 terabytes on there, and it's almost all full of notes. So I'm trying to get some of these things out there. But if I can help groups use the internet more effectively, then I do it. And that includes groups like Google has a lot of young people. They're very smart, but they don't have a lot of experience with all the things that are going on in the world. And if they, it's hard work. It took 2 years to get famine straightened out, okay? And I had 12 people working for me, okay? That was not a trivial thing. And that's just the staff there. And beyond that was all, the embassies and consulates and agricultural specialists and UN people and NGOs and all the organizations, a lot of people involved. I never did look at the count of all the people involved, but it was a relatively small scale effort in the whole to put it together, gather the information and draw conclusions from it. And you can do roughly the same thing with almost anything. So even though I talk about these things as relatively fast, you can do things maybe 100 times faster, but ultimately, because the data's in bad shape, you spend a good chunk of time just getting it there and doing the grungy. The reason I've been successful in my life a lot of times is I take the time and clean up the data. Okay, what was it? 1% inspiration, 1%, 1% inspiration, 99% perspiration. That's pretty true. Okay, it's fairly easy to be sure that something will work. Okay, if you put decades, there, but then you have to go and find all the pieces, and if nobody helps, it gets in. Anyway, now I'm really tired. I hope some of this is helpful. I hope it just springs one tiny little thing there. Maybe my whole purpose in life is to get one little idea to somebody who then goes and changes the whole universe or something. I don't know. All right. Thanks for listening.